let's continue your number 106. Halogen used as a common water disinfectant is letter D, chlorine. In the early days, chlorine has been used to purify the drinking water, and water is treated with an excess of gaseous chlorine plus carbon in order to absorb certain objectionable impurities. So the concentration of chlorine here is 0.2 part per 1 million. I repeat, the concentration of chlorine in order to become an adsorbent is 0.2 part per 1 million. So number 107, the transfer of solvent molecules through a semi-permeable membrane, that is your letter C, osmosis. Kapag nababasa nyo yung word na osmosis ay na semi-permeable membrane, that is connected to your osmosis. So the transfer of solvent through a semi-permeable membrane, that is your osmosis. Number 108, the weight of solute in a given quantity of water is known as your concentration. So, the weight of solute over a quantity of water. This may be expressed in molarity, normality, molality, and percent. So, kapag concentration naman, it is expressed as your molarity, normality, molality, and percent. Number 109, the chloride of this metal. The chloride of this metal is an astringent, antiperspirant, and deodorant. Again, lumabas na naman ito. That is your aluminum. The use of aluminum is astringent, antiperspirant, and deodorant. While your aluminum chloride component is employed externally as a general astringent and antiseptic. So, if the question is the external use of aluminum chloride, that is your general astringent and antiseptic. So, the solutions of aluminum chloride, 10 to 25 grams over 100 ml. It is used as antiperspirants and deodorant. Okay. Copper imparts a characteristic color to a non-luminous flame. The answer here is emerald green. Kapag sodium naman, your sodium ion imparts a persistent golden yellow color to a non-luminous flame. Your potassium will give violet. Your lithium will give a carmine red. Your calcium will impart a brick red. And lastly, your cupric is your green coloration. So I repeat, for sodium, persistent golden yellow. Sodium, persistent golden yellow. Kapag potassium, violet. Kapag lithium, carmine red. Kapag calcium, brick red. And kapag cupric, green coloration. Ayan. Weak electrolytes are poor conductors of electricity. So, kapag strong electrolytes naman, they are the strong conductors of electricity, and non-electrolytes are non-conductors of electricity. So, kapag strong electrolytes, strong conductors of electricity. Kapag weak electrolytes, they are poor conductors of electricity, and non-electrolytes, they are non-conductors of electricity. Number 112, examples of protective from inorganic compounds except your glycerol. So, the examples of protective from inorganic compounds, they are your kaolin, calamine, and zinc oxide. So the exception here is your glycerol or glycerin. They are prepared from saponification of fats and oils. And the process that is used here in your glycerol is your hydrolysis of fats and oils. So I repeat, if the question is prepared from saponification of fats and oils through hydrolysis, they are your glycerol and glycerin. Number 113, laughing gas is for letter B, anesthetic preparation. Your laughing gas is also known as your nitrous oxide. Laughing gas is also known as your nitrous oxide, which is used as an anesthetic. Number 114, heavy water is D2O. That is your deuterium. I repeat, that is your deuterium. It is an isotope of hydrogen. So deuterium is an isotope of hydrogen, which is also known as your heavy water. So heavy water is chemically the same as your regular or light water, but with 2 hydrogen atoms. So that is why D2O yung chemical component niya. So in summary, deuterium is an isotope of hydrogen, which is also known as your heavy water, which is the same as your regular light water but with 2 hydrogen atoms. Okay, number 115, element common to all acids, that is your hydrogen. So the presence of hydrogen in all acids, this would mean your examples of this are hydrochloric acid, sulfuric acid, ano pa ba? Phosphorus acid. Kapag ang question naman is element common to all bases, that is your OH or your hydroxides. OH or your hydroxides, such as examples, calcium hydroxide, magnesium hydroxide. Okay, number 116, for treatment of mental ailments, that is lithium carbonate. So lithium salts have been used in the mental hospitals for the treatment of mania. So lithium again is used for the treatment of mania. So kapag treatment of mental ailments, that is your lithium. That is the main use of lithium salts, such as your lithium carbonate. Okay, number 117, cinnabar is chemically your mercury sulfide. So mercury occurs nature chiefly as the red crystalline sulfide called your cinnabar. So the color of your cinnabar here is red crystalline sulfide, which is your HgS. It is found also in disseminated through rocks and as an amalgam of silver and gold. So cinnabar is also present in the amalgam of your silver and gold. Number 118, oxides of typically non-metallic elements are acidic. So oxides of typically non-metallic elements are acidic. So if the question here is oxides of metallic elements, that is your basic. So always take note for the differentiation. So oxides of typically non-metallic elements, that is your base acidic, and oxides of metallic elements are basic. Okay, 119. The law that expresses the relationship between pressure, volume, and temperature of gases in the equation PV and RT, that is ideal gas law. So memorize the equations of the gas laws. You should be familiar with those. Your Gay-Lussac's, your Boyle's, your Charles, and your ideal gas law. So, the question is asking for your ideal gas law. The equation is PV and RT. Okay, 120. The most active of metallic elements is your alkali metals. So, the most active of metallic elements are your alkali metals. Because they have a high affinity for oxygen and readily form the ordinary oxides as well as the higher oxides with both affinity and tendency for higher oxide formation increasing with atomic weight. So, alkali metals have a high affinity for oxygen and thus they are called as the most active of metallic elements. Number 121. Attractive forces created by the polarizability of molecules and are exerted when two uncharged atoms approach very closely. That is the definition of your van der Waals forces. That is the definition of your van der Waals forces. Attractive forces created by polarizability of molecules and are exerted when two uncharged atoms approach very closely. Number 122. This element is poisonous even in free metal form. The answer here is your mercury. So, mercury is the most poisonous element in your periodic table. Number 123. These are salts of chlorine except your saltpeter. So, the salts of chlorine are rock salt, bleaching powder, and your calomel. The salts of chlorine are rock salt, bleaching powder, and calomel. Again, your saltpeter is potassium nitrate, while Chile saltpeter is your sodium nitrate. Okay, 124. Benzalkonium chloride is a germicidal surfactant which is rendered inactive in the presence of your anion agents or your soaps. So, benzalkonium chloride is a germicidal surfactant which is rendered inactive in the presence of soap or anion agents. Why? Because benzalkonium chloride is a cationic surfactant. Benzalkonium chloride is a cationic surfactant. Number 125. It is the gas liberated upon the action of water on acids or metals whenever phosphorus is present as a contaminant. So, the word here is liberation of gas when phosphorus is present. That is your letter C, phosphine. Phosphine or phosphine. Number 126. Number 126. The technique used to detect the presence of trace amounts of metal contaminants. That is your atomic absorption spectroscopy. So, the main use of your AAS, your atomic absorption spectroscopy, is for analyzing metals and metalloids for the presence of trace amounts of metal contaminants. So, they are the one to detect the presence of trace amounts of metal contaminants. Number 127, dimercaprol or Yorbal acts as an antidote by a process called chelation. So, the mechanism of action of your dimercaprol as an antidote is chelation. So, it is an chelating agent in arsenic, gold, mercury poisoning. I repeat, dimercaprol is indicated as a chelating agent in arsenic, gold, and mercury. So, the treatment or the antidote for arsenic, gold, and mercury poisoning, that is your dimercaprol. Number 128. A solution made up of a weak base plus salt which resists changes in pH is your buffer solution. So, solution made up of weak base plus salt is your buffer solution. Letter A. Number 129. A solution made up of a weak calcium absorption pala. Calcium absorption and distribution are under a complex hormonal control of parathyroid hormone, calcitonin, and thyrocalcitonin. So, calcium absorption and distribution are under a complex hormonal control of the three: parathyroid hormone, calcitonin, and thyrocalcitonin. So, the answer here is letter D, all of the above. Potassium supplements are administered in all of the following manners except rapid IV injection. That is your letter B. Why? Because rapid IV injection or direct administration of your IV of potassium has caused or resulted to death of the patients. So, that is why the only preparation for potassium supplements are the following: IV infusion, elixir by oral, effervescent salts, and slow release by oral. Ayan. Number 131. After oral administration, the greatest amount of iron absorption occurs in your stomach or sigmoid portion of the large intestine. So, the answer here would be either B or C. So, it is known that the most active site for iron absorption is in the acidic duodenal section of the GIT, with lesser absorption in more alkaline intestinal tract. So, iron is most absorbed in an acidic environment. So, that is your stomach and your sigmoid portion of the large intestine. So, ang iron is less absorbed in more alkaline intestinal tract.